Why do bodies move? Aristotle's Cosmology, Modern Developments, and the Causes of Local Motion. An Aristotelian Thomistic Perspective on Gravity and Inertia. In the 20th century, St. Thomas Aquinas, the 13th century friar and theologian, has once again gained prominence as one of the most important historical figures influencing contemporary philosophy. What he is most famous for today are his so-called 5 ways, his 5 proofs for the existence of God given at the beginning of his magnum opus, the Summa Theologiae. Among these, the most famous and the most commonly used is the first way, or prima via. This is an argument from the existence of motion to the existence of an unmoved mover, which we call God. The problem is that living in the 13th century, St. Thomas significantly predated the scientific revolution of the 17th century, during which our understanding of motion and of the cosmos were dramatically altered. This might lead some to think, and some have claimed this, that Aquinas' argument for motion is now obsolete. It no longer works. In particular, there seems to be a conflict between one of Aquinas' key premises and Newton's first law, the principle of inertia. One of Aquinas' premises is that everything moving is moved by another. Omne quod movetur ab alio movetur. This principle postulates that whatever is moving has to have some external cause of its motion. This, on the surface, seems to conflict with Newton's first law, which stipulates that things will preserve their state of uniform rectilinear motion unless acted upon by an outside force. It's rather that things stop moving that requires a cause than that they continue moving in the same uniform motion that they're currently in. So, on the surface, it seems that Aquinas' argument is now obsolete in light of the notion of inertia. This video will not be offering a reformulation of Aquinas' first way. It's not a video on Aquinas' proof for the existence of God. Rather, what this video will address is the background information necessary for evaluating Aquinas' first way. In particular, it will be looking at Aquinas' medieval account of the causes of local motion, and it will look at these in light of his cosmology and considering it in light of more recent modern developments in the scientific revolution. Now, Aquinas' cosmology was largely indebted to 2 particular figures, Aristotle, the 4th century BC Greek philosopher, who founded most of the disciplines we now recognize as scientific, and Claudius Ptolemy, the 2nd century Greek-speaking astronomer who was revolutionary for formulating the system of the heavens, the system of the cosmos, and giving a mathematical discipline of astronomy that was used throughout the Middle Ages. Now, Aristotle's key works were the Physics, On Generation and Corruption, On the Heavens and the Earth, and Metaphysics 11 and 12. The most important of these is the Physics. The Physics is a general treatment of the causes of motion in general. It covers such topics as what is motion, what is time, what is place, and it gives a presentation of an argument from motion for an unmoved incorporeal mover. On Generation and Corruption is a specific treatment of motions below the moon, which for Aristotle were, as we'll see, were distinct from motions above the moon. On the Heavens and the Earth is important for clarifying how Aristotle understood the motion of the heavenly bodies. Why do they move? This is where we find Aristotle arguing that they're moved by incorporeal intelligences, something we'll come back to in this video. Metaphysics 11 and 12 presents one of Aristotle's most famous arguments for the existence of an unmoved mover from the existence of motion observable around us. A parallel argument can be found at the end of the Physics. Ptolemy's most important work is the Almagest, which presents his scientific or mathematical account of the motion of the heavenly bodies. This was used for more than a millennium after Ptolemy's death. Now, in the late Middle Ages, many thinkers, theologians, and philosophers began to be dissatisfied with Aristotle's account of one specific kind of motion, projectile motion. This is the motion, for instance, that we see in a cannonball flying from a cannon, or in a rock flying from a catapult or trebuchet. Aristotle's account of why objects move in these ways was clearly dissatisfactory, and it had obvious problems. These problems and debates about how to solve them led to some of the major developments in the scientific revolution, especially by Galileo. Now, since the scientific revolution, there have been significant developments in the 20th century. The subject of this video is going to ignore these major developments in the 20th century for the most part, but it will be worth at least highlighting them right now. So in the 20th century, the major developments are the development of the theory of relativity by Einstein, the special and general theory in 1905 and 1915 respectively, the development of quantum physics, also largely thanks to Einstein starting in 1905, and the Big Bang theory, which was importantly formulated by Father George Lemaitre. Now, these theories significantly change the way we view the cosmos and the causes of motion. This video will not be addressing these more recent developments, but will be focusing on the developments of the scientific revolution. Part 1. Mapping the Cosmos. There are three central theses to the Aristotelian cosmology. First, geocentrism. The Earth is a tiny sphere in the center of a vast, but finite, spherical universe. Second, the geostatic theory. The Earth is motionless. It neither rotates nor moves in place. Third, there's an Earth-heaven dichotomy. There's a distinction in kind between two cosmic regions, the heavens and everything below the moon. The sublunary realm is everything below the moon. The heavens, or the celestial realm, are everything the moon upward to the edge of the spherical universe. Everything in the sublunary realm is either one of the four elements, earth, air, fire, or water, or composed of these. Everything in the celestial realm, or heavens, is composed of a fifth element called ether. There are a few key entities in the heavens. First is the moon. Second is the sun. Third, there are these things called wandering stars. These are what we today know as the planets, but which at the time were thought of as stars. Fourth, there are the fixed stars. These include the constellations. The difference between the fixed stars and the wandering stars is that the fixed stars maintained their relation to one another as they moved across the night sky. In contrast, the wandering stars were always in a new location relative to the other stars. Finally, there's the primum mobile. This is an invisible first mobile body whose orbit constitutes the outermost boundary of the universe. It's because this body moves in its spherical orbit that the other orbits move, and that in turn we have seasons here on Earth. These heavenly bodies are all perfect, luminous, self-lighting spheres that are incorruptible and immutable, except for their natural change of place. The entire heavenly sphere, which holds the sun and other heavenly bodies, revolves around the Earth once every day from east to west, giving rise to the 24-hour day we experience here on Earth. Apart from this so-called diurnal or daily motion, each heavenly body has its own proper motion within the revolving heavenly sphere of which it is a part. In summary, Aristotle believed the cosmos consisted of two basic regions, the celestial realm, or heavens, and the sublunary realm, or everything below the moon. The key difference between these two regions is that the celestial realm was entirely composed of necessary beings, whereas the sublunary realm is entirely composed of possible beings. Now, what does this mean? The celestial realm is composed of substances that are incorruptible. They cannot be destroyed and turned into something else. They are likewise ungenerable. They cannot be made out of pre-existent matter. In other words, they have no internal principle by which they could have been made from something else or corrupted into something else. For Aristotle, these incorruptible celestial bodies were eternal and had been revolving around the earth through an infinite past. For Christian Aristotelians, these heavenly bodies, though still incorruptible and not generated from pre-existent matter, had been created from nothing, or ex nihilo, by God at a definite point in the past. In other words, for Christian Aristotelians, there's no opposition between saying that something was made at a definite point in the past out of nothing and saying that that thing could not be made from pre-existent matter. Likewise, there's no necessary opposition between saying God created something freely and could have not created it, on the one hand, and saying, on the other hand, that what was so freely created is created to be a necessary being that has no internal principle of corruption. Now, the sublunary realm consists of three basic entities: the four elements, mixed bodies, and living things. The four elements were, for Aristotle, the traditional Greek four elements: fire, air, water, and earth. These elements were believed to be homogeneous bodies that could not be divided into bodies distinct in kind from themselves. These elements each had their own chemical properties that belonged to them when they were found in their pure form. For instance, fire is always hot and dry. Water is always cold and wet. When the elements were combined, they could form something called a mixed body. Mixed bodies were inanimate things such as minerals, which were composed out of the four elements and could be corrupted back into the four elements. Living things were animated things, things with a soul, that is, a principle of vital activity. Plants were capable of the vital activities of nutrition, growth, and reproduction. Animals added to this the vital activity of sensation, or imagination, memory, instinct. Humans add beyond the vital activities of plants and animals the vital activity of reason, or intellect. Thus, plants, animals, and humans each have a soul, or principle of vital activity, and that's what distinguishes them from mixed bodies and elements. In summary, the Ptolemaic and Aristotelian cosmologies were geocentric and geostatic. They held that the Earth is the motionless center of a finite spherical universe composed of a series of perfect concentric circular orbits, at the bottom of which was the orbit of the Moon. And they also held an Earth-heaven dichotomy, the view that there's a difference in kind between the stuff below the Moon, which is all generable and corruptible, and everything the Moon on up, which is a necessary and self-illuminating being. Now, in the early modern period, there were a series of alternative proposals for how the cosmos should be understood. We'll briefly touch on these for the sake of context. One was that of Tycho Brahe, who was an important transitional figure. His observations were important for transitioning from the old Ptolemaic system to the newer systems of Galileo and Newton. Tycho Brahe held a hybrid between geocentrism and heliocentrism. For him, the sun still orbited the Earth, which was the motionless center of the universe. Yet, everything else in the universe besides the Earth's moon orbited the sun before orbiting the Earth. In other words, everything orbited the Earth indirectly by first orbiting the sun, which itself orbited the Earth. More importantly were the developments of Galileo and Kepler. Galileo embraced the view of the earlier astronomer Copernicus. Copernicus had revived the view of the ancient Pythagoreans that the Earth orbits the sun rather than vice versa. Galileo added to this observations with the newly invented telescope. He discovered that the celestial bodies above the moon were corruptible and generable and composed of the same sort of stuff as things here on Earth. In other words, he abandoned the Earth-heaven dichotomy and was justified in doing so thanks to his telescopic discoveries. The things above the moon are no longer viewed as self-illuminating, necessary beings, but rather as opaque, corruptible beings just like things here on Earth. Johannes Kepler accepted this view, but added to Galileo's view that the orbits in the heavens were actually not perfect circles, but instead elliptical. Now, the most important development here was the abandonment of the Earth-heaven dichotomy. This was crucial for Newton's later formulation of the principle of universal gravitation, the idea that all the heavenly bodies move for the same reason as the things here on Earth, namely due to gravity. Now, contemporary or 20th century cosmology has advanced well beyond these early modern theories. We do not have time in this video to discuss all of the novel proposals for how to understand the geometry and shape of the universe. What we will discuss is the fundamental thesis of contemporary cosmology, which is that the universe is non-Euclidean. What does this mean? Well, in a Euclidean universe, if you draw two parallel lines, these lines will never touch each other. They could go on forever and they won't touch. In a non-Euclidean universe, the universe, though three-dimensional, is analogous to the two-dimensional surface of a three-dimensional ball. Now, imagine a ball that's three-dimensional, and imagine that you are on the surface of this ball, let's say as an ant. If you draw two parallel lines rising from the equator of this ball, they're parallel because they're moving upwards at 90 degrees. These lines will eventually touch each other. In the same way, if you draw two parallel lines in a non-Euclidean universe, these lines will eventually touch. So, while the Earth does orbit the Sun in contemporary cosmology, neither the Earth nor the Sun is the center of the universe. In fact, and very importantly, there is probably no center to the universe, just as there is no center to a non-Euclidean two-dimensional surface on a three-dimensional ball. Notice that on this ball, in this image, there is no center. Likewise, in our own universe, there is no center, or at least that's most likely the case. Our universe is analogous to the finite but centerless non-Euclidean surface of a ball. The genera of motion. Before we discuss the causes of motion, we first need to distinguish the different kinds of motion which need a cause. Now, Aristotle distinguishes four kinds or genera of motion. These are first, generation and corruption. This is when a substance comes to be or ceases to be, simply speaking. When two squirrel parents, for instance, make another squirrel. Another kind of motion is alteration, or as it's sometimes called, change in quality. This is when a substance changes one of its qualities into another one. For instance, when a man goes from being pale to tan in the summer. A third kind of change is growth or diminution. This is when a substance increases or decreases in quantity. For instance, when a tree grows from a seedling to its proper height, or when an old man begins to shrink. A fourth kind of change is local motion, or locomotion, or change in place. This is when a body changes its location. For instance, when a rock falls from a high place to the ground. This basic division of motion into four genera, or kinds, was a commonplace in physics from Aristotle's day until the modern era, and was accepted by Thomas Aquinas. In this video, we'll specifically be looking at the causes of local motion, or locomotion, that is, change in place. For Aristotle and Aquinas, alteration and growth and diminution were ultimately dependent on local motion as the most fundamental kind of accidental change. There are reasons to doubt whether this is the case today, but for the sake of this video, we're just going to be focusing on local motion, which is, at least in some way, fundamental. Aristotle divides local motions into two basic kinds, natural local motions and violent ones. Natural ones are motions that arise from a proper internal principle of motion or rest. In other words, they come from within. In contrast, violent local motions are contrary to nature and arise from an external mover or force. The natural local motions are divided according to the different sorts of natures there are. But as we saw earlier in our discussion of Aristotle's cosmology, there are four basic sorts of natural things for Aristotle: heavenly bodies, the four sublunary elements, mixed bodies composed of the elements, and living things composed of the mixed bodies and elements. This gives rise to several different kinds of natural local motion. First, let's look at the simple kind. Simple natural local motion belongs to the elements in their pure form and celestial bodies. Now, the elements in their pure form move either upward or downward depending on the element, and moreover they always accelerate. So fire and air accelerate upward and earth and water accelerate downward. The celestial motion is an unaccelerated circular motion. Apart from these simple motions, there are several composite motions. First, there's the composite motion of bodies that results from their being composed of multiple elements. So for instance, the helical downward motion of a leaf falling from a tree is based on the fact that, according to Aristotle, it's composed of earth, water, and fire in different proportions. Now, there are also vital motions, such as the motion of a dog walking around in search of food, which arise from the soul of the animal moving. Violent motions are motions contrary to nature. For instance, if I throw a rock upwards, since the rock is primarily composed of earth, this is a violent motion since it's contrary to the nature of the rock. Rocks are supposed to go down, not up. Projectile motion is another kind of violent motion. It's, for instance, the motion that a cannonball will take when it's shot in a direction perpendicular to free fall. Since the cannonball is primarily composed out of earth, it should move downwards, but instead it's moving horizontally or in a direction perpendicular to the free fall it's naturally supposed to follow. As we'll see momentarily, modern physics manages to explain both the round motion of the heavenly bodies as well as the upward motion of fire and air in terms of a general tendency of massive bodies downward toward the center of mass. Aristotle didn't know that this reduction of the natural motions of fire and air and of the celestial bodies to the natural motion of earth and water was possible. But that doesn't mean that he wasn't correct in some sense. Within the limited domain that he was dealing with, his observations were right, that fire and air do move upward, and earth and water move downward, and the celestial bodies move in a circle, or roughly a circle. A simple illustration of the point that Aristotle was right about fire and air moving upward is this. If you want to light a candle that's getting low and it's in a glass container, you turn the candle upside down. If you try to light it from above, you'll burn your finger. But if you turn the candle upside down, the fire will move up to the candle's wick. In other words, within the limited domain that Aristotle had observations for, he was correct that fire and air do move upward and that celestial bodies move in approximately, though not perfectly, a circle. Part 3. The cause of natural downward motion, or gravitational freefall. There are several possible explanations available in theory for why massive bodies like rocks, apples, and dogs fall downward when unimpeded. Probably the one people are most likely to think of today is that massive bodies are pulled downward either by the center of gravity or by other massive bodies, which attract the falling body to themselves. This is the pull of gravity theory, and it can be formulated in one of two ways, depending on whether you think that the body that pulls using some instrument analogous to a rope, or pulls without any such instrument, that is, without even touching the object pulled, even indirectly. A second option is to conceive of the falling body as being pushed rather than pulled downward. This is the conjoined mover theory. And this again can be formulated in one of two ways, depending on whether one conceives the mover as another body or as a spiritual or incorporeal mover like an angel. Although Sir Isaac Newton is often associated with the pull of gravity theory, he explicitly denied he held this view, or at least he explicitly denied he held the view which I have labeled in this video 1b. And instead, he seems to have favored the view that I've labeled 2b, namely that there's some spiritual or incorporeal mover that moves bodies downward. For him, view 1b, the theory that falling bodies are moved by distant massive bodies without any means of physical contact, was too absurd to be entertained. Quote, that one body may act upon another at a distance through the vacuum, without the mediation of anything else, by and through which their action and force may be conveyed from one to the other, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. Newton was explicit that when he spoke as if bodies quote-unquote attracted or pulled each other at a distance, he was speaking in a way useful for mathematical descriptions and experimentation, but not attempting to give the true physical cause of downward motion, of which he admitted he was ignorant. Quote, Hitherto we have explained the phenomena of the heavens and of our sea by the power of gravity, but have not yet assigned the cause of this power. This is certain, that it must proceed from a cause, but hitherto I have not been able to discover the cause of those properties of gravity from phenomena, and I frame no hypothesis. I here design only to give a mathematical notion of those forces without considering their physical causes and seats. I am considering those forces not physically, but mathematically." End quote. Newton did entertain the possibilities, however, that falling bodies may be pushed or pulled by some other bodily or spiritual agency. In other words, he considered the possibilities 1a, 2a, and 2b all as plausible and on the table. Quote, "I here use the word attraction in general for any endeavor whatever made by bodies to approach each other, whether that endeavor arise from the action of the bodies themselves, as tending to each other, or agitating each other by spirits emitted, or whether it arises from the action of the ether, or of the air, or of any medium whatever, whether corporeal or incorporeal, in any manner impelling bodies placed therein towards each other." End quote. Now, the remaining options 1a, 2a, and 2b each face their own difficulties. First, we can leave aside 2b for now. Most people will probably agree that we should avoid appealing to any spiritual movers unless no other, purely natural explanation suffices. Second, theories 1a and 2a simply kick the can down the road. They do not offer an ultimate natural explanation for local motion, since they simply explain the downward motion of one body by the downward motion of another body, pushing or pulling the moved body. This simply pushes off the problem of explaining downward motion. We still must somehow explain the downward motion of the pushing or pulling body. This brings us to the third theory entertained by Newton, the one closest to that of Aristotle, namely that heavy or massive bodies simply have their own internal principle of downward motion and are not moved by any external conjoined mover. But this can be formulated in one of two ways. The first option is to interpret this in the way that Averroes seemed to have interpreted Aristotle. According to this view, to say that bodies have their own internal principle of downward motion is to say that they have within themselves an efficient cause of their own downward motion. They have within themselves a sort of effective mover of their downward motion. Now, this efficient cause could itself be either a body or an incorporeal agent, such as a spirit or angel. Now, if you hold this interpretation of view 3, it effectively reduces to view 2, because to say that every body has its own internal agent of its own downward motion, whether another body within it or a spirit within it, is effectively to say that bodies fall because they're pushed downward by either another body or by a spiritual mover. In other words, view 3a collapses to view 2. But there's another way to interpret view 3, and that is view 3b. On this view, there is an internal formal but not efficient cause of downward motion within falling bodies. This is how Aquinas interpreted Aristotle. On this view, bodies fall because they have their own formal but not efficient principle of downward motion, and there is no conjoined mover or pusher for natural downward motion, whether that conjoined mover be something quote-unquote internal or external. Newton himself rejected formal causality and seemed to hold something like view 2b or 3a. For Aristotle, heavy bodies like rocks, water, trees, and dogs naturally move downward simply because it is in their nature to do so. Birds fly, dogs bark, and heavy bodies move downward. Put more technically, the elements of earth and water, and whatever is composed of these, e.g. minerals, plants, and animals, have a certain accidental form or quality called heaviness, or in Latin gravitas, which naturally belongs to them in virtue of their nature. Aristotle's notion of heaviness or gravitas is analogous to the modern notion of gravitational mass. Gravitas is a quantifiable quality in virtue of which bodies are inclined toward the center of gravity, or, as Aristotle called it, the bottom. If unimpeded, bodies with gravitas will always spontaneously begin to move downward until they reach the center of gravity, or the bottom, at which point they will stop moving and naturally come to rest. A heavy body's resting in its natural place is again caused by its gravitas. Thus, for Aristotle, there is no conjoined force or external agent needed to pull or push heavy bodies downward. They simply move downward through their own formal principle. If we are to identify some agent, efficient cause, or mover responsible for the natural downward motion of heavy bodies, it is not something conjoined to the falling body, pushing or pulling it through its journey, but instead whatever gave that falling body its natural quality of gravitas, in virtue of which it is naturally inclined to fall spontaneously when unimpeded. So, for instance, when unimpeded, squirrels fall because their parents made them to be squirrels, and squirrels are, by nature, heavy bodies, which, if unimpeded, will spontaneously move downward. Importantly, while the efficient cause, or agent, of natural downward motion needs to have touched the body it moves initially in order to give it its quality or gravitas, it does not need to continue touching it or even to continue existing for the affected body to keep moving downward. Once a body has acquired the quality of gravitas, it will spontaneously move downward on its own without any conjoined mover. For Aristotle, the mirror image of natural downward motion is natural upward motion. Just as heavy bodies like rocks, trees, and squirrels, when unimpeded, fall downward until they reach their natural place, so too light bodies like air and fire, if unimpeded, naturally rise upward until they reach their natural place. The quality that formally causes downward motion in heavy bodies is called gravitas or heaviness. The quality that formally causes upward motion in light bodies, like air and fire, is, for Aristotle, called levitas or lightness. For Aristotle, the natural place of the element, earth, is at the bottom, i.e. the center of the universe, which for Aristotle is also the center of the earth. The natural place of water is just above the layer of earth. The natural place of air is just above water, and the natural place of fire is in a spherical layer just above air and below the moon. Thus, since the elements, when unimpeded, spontaneously move to their natural place, the sublunary realm, if unimpeded by forces outside the sublunary realm, would gradually unravel into a perfect four-layered cake with earth at the bottom, water just above that, air just above water, and fire at the top. At this point, since everything was in its natural place, all motion below the moon would cease. Part 4. Reducing celestial motion to projectile motion. We have now explained natural sublunary motion. The motions of living things and mixed bodies are ultimately explained by the motion of the elements, of which mixed bodies and living bodies are composed. These elements in their pure form naturally accelerate in a rectilinear motion toward their natural place. The formal cause of the elements' natural rectilinear motions are their respective proper qualities of heaviness or gravitas for earth and water, or lightness, levitas, for fire and air. The efficient cause of the natural motions of these elements are those agents that first generated those elements with their respective natural qualities. For Aristotle, no conjoined mover or efficient cause is needed to explain the natural downward or upward motion of the elements, or what is composed of them, below the moon. The circular motion of the celestial bodies and curved motion of projectiles present a special problem for Aristotle, to which we now turn. As we have now seen, Newton pleaded ignorance as to why heavy bodies moved toward one another, but favored the view that this was due to a conjoined spiritual mover. Aristotle and Aquinas saw no need for such a conjoined mover, spiritual or otherwise, to explain natural downward motion. For them, this motion was simply a natural resultant of the internal quality of gravitas present in heavy bodies. The mover of these bodies was not some conjoined mover or spirit, but only whatever gave the moved body its quality of gravitas in the first place. When it came to the circular motion of celestial bodies, however, Aristotle and his medieval disciples like Aquinas, Avicenna, and Averroes did see the need for conjoined spiritual movers, which Aquinas identified with the angels in Hebrew and Christian scripture. The reason was that the circular motion of these bodies seemed in principle to be infinite. It did not seem to be directed at coming to rest in any particular place. As a result, the motion of these bodies did not seem to be the product of any finite body, but of an infinite and incorporeal intellect that had some non-corporeal end or purpose in moving the celestial bodies in indefinitely repeating circular orbits. Aristotelians differed among themselves about the precise nature of the spiritual movers of the heavenly bodies. Some said these were the souls of the heavenly bodies, and the heavenly bodies were rational animals. Others, like the Persian Muslim Aristotelian Avicenna, said the heavenly bodies were moved by the combined effect of rational souls and separate pure intellects. Still others, especially in the Christian West, denied that the heavenly bodies were animated by rational souls, and instead held that the heavenly bodies were moved only by pure intellects, which were not themselves the souls of any body. Aquinas held this final view, and added that these pure intellects were the angels described in Hebrew and Christian scripture, though not all his Christian Aristotelian contemporaries agreed with him. Ancient and medieval Aristotelians also differed with regard to why the spiritual movers move the heavenly bodies. These Aristotelians each offered their own possible explanations for what motivated the incorporeal substances or separate intellects to move the heavenly bodies in indefinite circular orbits. Avicenna proposed this was a sort of cosmic liturgy in which the heavenly bodies worshipped Allah by imitating him. They imitated him as the one necessary being by making the heavenly bodies they moved occupy every place they could possibly occupy as frequently as possible, that is, by moving in repeated perfect circles. Aquinas proposed that the motion of the heavenly bodies was ordered toward causing generation and corruption on earth, so that the predestined number of humans could be generated and their souls brought to eternal life in heaven. Once the preordained number of humans had been born and their souls redeemed, the motion of the heavenly spheres would cease. Thanks to Galileo's discoveries with the telescope, invented in 1608, and Galileo's and Newton's novel arguments concerning projectile motion, it became possible to abandon the traditional Aristotelian Earth-Heaven dichotomy and to treat the quasi-circular motion of the heavenly bodies as merely a special instance of projectile motion. Thus, the ancient and medieval Aristotelian theory that the heavenly bodies were moved by spiritual movers could be abandoned, that is, on the assumption that projectile motion itself could be explained without appeal to spiritual movers. Let's take a look at the basic argument for reducing celestial motions to special instances of projectile motion. Premise 1. Heavy bodies naturally tend downward in a straight line. This is accepted by everyone, including Aristotle. Premise 2. Quote, every body perseveres in its state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by forces impressed. End quote. This is Newton's first law, or the principle of inertia. What it means is basically this. Bodies with inertial mass tend to preserve their velocity. What requires an external efficient cause, then, is not uniform motion perpendicular to gravitational freefall, i.e. the tendency of a projectile to move horizontally, but instead changes to this motion, i.e. accelerations or decelerations. Premise 3. The downward gravitational tendency and horizontal inertial tendency of a body can be combined to form a mixed parabolic motion we associate with projectiles. With enough horizontal speed, a projectile can fully orbit a circular massive body by falling toward the body slower than the body's surface curves away from it. Take the example of a cannon fired from the Earth's surface. The cannonball will have a horizontal tendency due to inertia, as well as a downward tendency due to gravity. These will combine into a mixed parabolic motion that is due to both gravity and inertia. As the cannon is fired faster and faster, the Earth's surface will begin to curve away from it before it can touch the ground. If it's fired fast enough, it would curve all the way around the Earth and continue in a quasi-circular orbit. Finally, premise 4. The heavenly bodies, like rocks and trees here on Earth, have both gravitational mass and inertial mass. In other words, they are heavy bodies with a tendency both to accelerate toward other heavy bodies and a tendency to preserve their state of uniform motion, excluding accelerations due to gravitational mass unless acted upon by an outside agent. In other words, when we abandon the Earth-heaven dichotomy and we accept that the heavenly bodies are subject to both gravity and inertia, and beyond that we accept the theory of the combination of motions where you could combine the tendencies due to gravity and inertia, it follows that it's possible for a body to continue in a quasi-circular orbit merely on the basis of the principles of projectile motion. The causes of projectile motion. We have now explained all natural sublunary motion by reducing vital motions and composite motions to the motions of the elements out of which living and composite bodies below the moon are composed, and by explaining the natural rectilinear motion of the elements by certain natural qualities such as gravitational mass or heaviness, gravitas. We have also now reduced the quasi-circular motion of the heavenly bodies to special instances of projectile motion, which itself is the result of a combination of natural downward motion and an inertial tendency in bodies to preserve their state of uniform motion. It remains then for us to discuss the cause of this inertial tendency for a body to preserve its state of uniform motion perpendicular to gravitational freefall. The cause of the inertial tendency in bodies is something that remains hotly disputed and insufficiently explored in contemporary philosophy of science. For Aristotle and Aquinas, projectiles, like rocks hurled from catapults, can only continue to move in a direction perpendicular to their downward tendency as heavy bodies because they are pushed by the air. In other words, when a catapult launches a boulder, it simultaneously pushes the air around the boulder, which in turn creates a domino effect in which the one patch of air moves another patch of air, and so on, carrying the boulder toward its target. It doesn't take much imagination to see that this traditional explanation of projectile motion is woefully inadequate. Maurice Finocchiaro, a leading historian of the Galileo affair, summarizes the evidence against the Aristotelian theory that air causes projectile motion as follows, quote, "The more easily ascertainable fact is that the cause of projectile motion is not the motion of the surrounding air. The reasons for this are that a. Wind moves cotton more easily than rocks, and yet rocks can be thrown farther and more easily than cotton. b. Lead pendulums oscillate much longer than cotton ones. C. If the force cannot be impressed directly by the thrower to the projectile, then it cannot be impressed directly by the thrower to the air. And D. Arrows can be shot against the wind." In other words, there are many conceptual and empirical problems with the theory that the reason projectiles move in a horizontal direction is that they are carried by the wind. In the late Middle Ages, several philosophers or theologians in the Aristotelian tradition proposed viewing the horizontal tendency of projectiles as due not to the air functioning as a conjoined mover, but instead to an accidental form or inclination impressed directly into the projectile by the thrower. Some held that because the form or inclination is finite, it should of its own accord gradually diminish over time. The problem is that, apart from air resistance, friction, or other counteracting forces, bodies do not actually decelerate in a horizontal direction when thrown. This can be inferred from the following two observable data points. 1. When bodies are dropped from an inclined plane, they accelerate, but 2. When they are projected up an inclined plane, they decelerate. It follows that along a flat surface, apart from the effects of friction and air resistance, bodies would tend to preserve their velocity, neither decelerating nor accelerating. Thus, other medieval thinkers like Jean Buridan posited that the thrower impressed a certain form or quality called an impetus into the projectile, which would carry a projectile in the direction thrown indefinitely unless diminished by counteracting forces like air resistance. The problem with this alternative theory is that the quality in question seems to be infinite and spiritual, beyond the capacity of any finite bodily mover to introduce. A more plausible theory, in my opinion, is to view the horizontal tendency of projectiles as a component of natural downward motion due to gravitational mass. While gravitational mass, or gravitas in scholastic parlance, is a quality that determines a massive body to accelerate constantly toward other massive bodies, it does not of itself determine the trajectory or path through which a massive body will move toward the sum of all other massive bodies. This trajectory or path of gravitational freefall is, I hypothesize, instead determined by an additional quality impressed by whatever agent most recently accelerated or changed the velocity of the falling massive body. This additional quality, which we may view as the formal principle underlying a body's quantitative velocity, is analogous to the medieval impetus in that it is a formal principle in the projectile impressed by whatever threw it. But it is unlike the medieval impetus in that the form impressed by the thrower does not incline a projectile to move indefinitely in a horizontal direction, but instead to move to a definite end, whether this be described as the center of gravity or other massive bodies, in a particular way, i.e., with a particular intensity and along a particular path. Thus, unlike Buridan's impetus, the form impressed by the thrower on this theory need not be infinite, but only finite. If the theory just described is correct, then all projectile motion, and therefore the motion of the heavenly bodies, requires 2 efficient causes and 3 formal causes, but no conjoined movers. First of all, projectile motion requires a form or quality called gravitational mass, or gravitas, by which the projectile is naturally or formally inclined to constantly accelerate when unimpeded toward other massive bodies. Notice this is slightly changing the way gravitas was understood in the medieval scholastic context. There, gravitas was an inclination to move locally towards the center of gravity, or towards the bottom. Here, gravitas is reinterpreted as a formal principle of constant acceleration, or changes to local motion, not a principle immediately of local motion. Since gravitational mass, or gravitas, is now understood as formally a principle of constant acceleration, that is, of constant changes to the intensity and direction of local motion, not of local motion itself, there must be some other formal principle of inertial mass by which a body is formally inclined to continue moving locally at whatever intensity, that is, speed, and direction it is given by external agents. Finally, since massive bodies do not, by the mere fact of their gravitational and inertial masses alone, have a specific velocity, speed, and direction, there must be some other formal principle communicated to massive bodies by external agents according to which their motion has a specific intensity and direction. This quality, which has no conventional title, but which we can for convenience call ontological velocity, is constantly changing due to a. the constant application of accelerating and decelerating forces by external agents, and b. the constant natural accelerative tendency resulting from gravitational mass. A body's ontological velocity, which it has at any moment, would explain the sort of quantitative velocity or quantified velocity which we could calculate using the distance equals rate times time formula. But ontological velocity should not be confused with its quantitative velocity because the one is a momentary quality, whereas the other is calculated over the process of a whole motion, which can't occur in any one instant. Ontological velocity should be understood as a determination or a quality determining a body's inertial mass. Apart from these three formal principles, every projectile also requires 1. An agent or efficient cause to make the mobile body the sort of body that it is, namely a massive one, that is one with a tendency to accelerate spontaneously if unimpeded to the center of gravity, and a tendency to preserve its current ontological velocity. And 2. An agent or efficient cause to produce the ontological velocity in question. Just as Aristotle and Aquinas, unlike Newton, did not require any conjoined mover for natural downward motion, so too we can conclude that inasmuch as projectile motion is now reducible to natural downward motion, projectile motion does not require any conjoined mover or agent presently touching the mobile body and pushing or pulling it along its path. It is important to see that with this new Aristotelian theory of projectile motion, based on a combination of Aristotle's theory of natural downward motion and the modern Newtonian principle of inertia, it is no longer the case that any corporeal agent can directly push or pull another body. No agent can directly change the place of another body without first altering the locally moved body. Let me explain. When one agent pushes or pulls another body, what actually happens is this. First, the mover alters the moved body by changing its ontological velocity, or redetermining its inertial mass, in a way proportionate to the direction and intensity of force applied by the agent. 2. Thanks to its gravitational mass as well as the new ontological velocity impressed by the external agent, the mobile body continues to move toward its natural destination, i.e. other massive bodies, but it does so according to a new trajectory determined by a combination of its old trajectory and the new contribution made by the most recent agent to act upon the mobile body, accelerating it at a specific intensity in a specific direction. Regardless of whether one accepts the novel account of the internal and external causes of projectile motion described on the last slide, two things remain true for any rational explanation of the phenomena of projectile or inertial motion. 1. If massive bodies can be generated, there must be or have been some agent, whether present or past, that accounts for the fact that any given massive body is, at present, a massive body, that is, one inclined to accelerate toward other massive bodies. 2. Insofar as massive bodies do not have a fixed or immutable velocity, but can be accelerated by external forces, i.e. subject to compulsory changes in speed and direction, it follows that there must be some agent, whether present or past, that accounts for the fact that any given massive body follows the specific trajectory at the specific intensity it does toward the center of gravity. Newton's first law, the principle of inertia, rules out the need for any conjoined mover to explain the tendency of bodies to preserve its present velocity. In fact, as I have argued above, Newton's first law makes the very notion of a conjoined mover conceptually dubious. No body directly changes the place of another. Rather, movers directly alter, qualitatively change, the state of motion of the bodies they move, with the result that local motion along a certain trajectory and at a certain intensity naturally results from the alteration introduced by the mover. Nevertheless, it is a mistake to think that Newton's first law vitiates the need for movers altogether. Even with the principle of inertia, the old scholastic axiom that everything moving is moved by another, omne quod movetur ab alio movetur, remains true. Every locally moving body, at least every locally moving massive body, supposing for the sake of argument there are massless bodies, is moved by an external agent. Specifically, every locally moving body is moved both A, by the agent that made it a massive body in the first place, and B, by the various agents that determined it, through the application of force, to move toward other massive bodies at the specific intensity it currently has along the specific trajectory it currently follows. Why does the arrow fly toward a target? It would be absurd to say no one moves the arrow or that it moves itself. Rather, it is common sense that the reason the arrow flies as it does is because it is moved to do so by the archer and by the fletcher, by the one who made the arrow to be the sort of mobile body that it is, and by the one who most recently determined the trajectory of that mobile body. The fact that there isn't a conjoined mover, that the archer isn't following the arrow, holding it in his hand, moving it to the target, does not mean that the archer didn't move the arrow.